dependent and independent events. So we're going to define what they means. What are dependent and independent events? So we're going to do an introduction. So let's look at a simple problem. There are 2 red marbles and 3 blue marbles. 2 marbles are selected, and let A be the event that a red marble being selected. Let B the event that a blue marble is being selected. Cool. Okay, so hang on. All right, let's continue. So there are 2 red marbles and 3 blue marbles. 2 marbles are selected. Now with replacement, so A be the event be a red marble, and then B be the event for the blue marble, right? Okay. Okay, so we're going to write this again. Didn't write well. Okay, so A and then B. Now remember, the probability tree diagram works like this. So you get 2 in 5 chance it is a red, 3 in 5 chance it is a blue. Yep, so write this down. And then what you do next is, now because there's a replacement, your chance of getting red again doesn't change. And your chance of getting blue again doesn't change. And then you're going to do A and B again. Same thing, 2 out of 5 and 3 out of 5. Because you put it back, yep. Orange. Yellow. Oh, we're going to calculate things. All right, where's my thing? Okay, good. Let's calculate the probability of a red marble, PA. So PA is just one event. Getting a red is just 2 out of 5. 2 out of 5. Actually, we have to add something more. Okay. No, not yet. Okay, let me take. Okay. Now, what you do is, this is not just A, it's A given A. Means that I'm getting a red marble given the first marble is red. This is getting a blue marble given the first marble is red. And this is getting a red marble after the first marble is blue. And the last one is a blue marble given the first marble is blue. Right? That's conditional probability. So for probability of getting a red marble, just 2 out of 5. But for probability of A getting a red one, given that the first one is given the first marble is blue, right? So which is this one here, given the first marble is blue, is still 2 out of 5. Okay, so the first one is the first marble is red, which is 2 out of 5. The second one means the probability of getting a red marble given the first marble was blue. So as you can see, these two are the same when there are replacement. Let's look at the case when there is no replacement. Your tree diagram would change slightly. You have a red or a blue, which is still 2 out of 5, 3 out of 5. And then when you get the red again, you write red given it is red, and then blue given it is blue, given the first one is red. So given the first one is red, the second marble could be red or blue. Your chance of doing that without replacement will now change, will be 1 out of 4, 3 out of 4. Like that. And the next one is given it is blue, the next marble is red. Given it is blue, the next marble is blue. Like that. And your chance of getting a red marble given it is blue, it is now going to be 2 out of 4. And the chance of getting a blue marble given the first marble was blue, because one blue was taken out, was also 2 out of 4. Okay, so we got that. So now we're going to answer this question, probability of getting a red marble. Red marble will be 2 out of 5, like that. But for the second one, probability of getting a red marble given the first one was blue is now changed to 2 out of 4. In this case, they are not equal. So probability of getting red is different from if you get red given that the first one is blue, right? Whereas for the first one, they are equal. Probability of getting a red is same as probability of A given B has happened. So one is equal, one is not equal. If it's equal, we say the two events are independent of each other. Getting a blue marble first doesn't affect your chance of getting a red. So we say A and B are independent. So that's what independent means that if something has happened, if it doesn't affect your second thing being happened, then they're independent. Whereas this one, you say the two events, A and B, are dependent of each other. It depends on whether you get blue marble or not. So you change your probability. Let me write this clearly because it's a bit hard to read. Let's write here, are independent. Okay, so that's the meaning of dependent and independent events. Explain this simple problem. What do I have to write here? Doesn't say. Okay, I'm supposed to write it over here, sorry. Okay, so let's write it back again. Okay, let's start again. So with replacement, we see that probability of A is equal to probability of A given B has happened. And then you do probability of, without replacement, they are not equal. They are not equal, okay? So what you do is that's independent. We say this is independent. A and B are independent. A and B are independent. Whereas the other one, A and B are dependent or not independent. Okay, because the result of B affected your chance of getting an A. Whereas this one, when B has happened, it didn't affect your chance of A happening. So one affects the probability of the event, one doesn't happen. One doesn't affect. If it affects it, it's not independent. If it doesn't affect, it is independent. Okay, so what you do is, let's move on. Yep, so that's the summary over here, okay? So for multiple events with selection made with replacement, events are independent. For multiple events with selection made without replacement, the events are not independent. Okay, so that's the meaning of dependent or independent. Let's highlight this. Let's put a highlighter. So that's the meaning of independence. All right, any question? So remember that for the exam. Yep. Continuing, we'll go to the next page. We'll do an example. Do example. Example 1. All right, let's continue. Example 1. We're going to get a student to read. Who want to read? Anyone? Okay. Jaden. Maybe ask another student. Okay. All right. Yeah.
A selection of 10 mobile phones offers 4. Sorry. A selection of 10 mobile phones offers 4 with free connection, 5 with a free second battery. Whereas one has offer both has free connection. Let A and B event choose a mobile phone with free connection. That B choose a mobile phone with free second battery. Summarize the information about the mobile phone.
Okay, so selection of 10 mobile phone offers include 4 with free connection and 5 with free battery. Okay, let's call this A be the event with a free connection, B for the event with free battery. Okay. Okay. All right. So we're going to some mobile phone offers both. So one offer has both free connection and a free battery. So what we do is we write one in the middle that has got both A and B. So that means if there are 4 with free connections, Therefore, because there's already one that has got both, how many has got only 3 connections without the free battery? So there are 4 with 3 connections, but one has got both free connection and a free battery. How many? There are 3. So there are 4 altogether. 1 plus 3 is 4, so there are 4 with free connection. And how about B? Choose a mobile phone with free battery. So how many has free battery? 5. So how many has got free battery only? 4. Good. Now remember there are 10 mobile phone pairs. So if I subtract all of these, what do you get? 2. So you get 2 left. We have got no free stuff. Okay, so we summarize this on a Venn diagram, and then we can answer the question. Okay. All right, let's look at the first question. PA. Probability of A happening. PA means that 3 plus 1, isn't it? So you get 3 plus 1 over 10, which is 4 out of 10, 2 out of 5. Okay? Now we're going to calculate the conditional probability. Find the probability of A given B has happened. Okay? So, given B has happened, given that it has a free battery, how many mobile phone has free battery? How many player has free battery? 5. There are 5 has got free battery. Out of the 5, how many of these has got a free connection? 1. So write 1 out of 5. Get the idea? So 1 out of 5 has got free connection out of the one that has got free battery. Alright, now we can answer the question, is A and B independent? Well, obviously, PA is equal to 2 out of 5, whereas P given A given B, it is 1 over 5. So they are different, isn't it? So if they are not the same, therefore PA not equal to PA given B. So what do we say? They are not independent. A and B okay, now A and B are not independent. Not independent. Okay, good. Okay, good. So there's another way to check whether independent is to use this formula. Okay, where does this formula come from? Yeah, let's calculate this. Another way to check if they are independent. Okay, good. So what we do is we can check whether it's independent by calculating these two separately and check whether they are equal or not. So we calculate P and A. Probability both bonus are given, so which is just 1 out of 10, like that. And then you find the probability of A times the probability of B. Probability of A is 4 out of 10. Probability of B is 5 out of 10. And if we times them together, what do you get? You get 20 out of 100, which is 1/5. Now, clearly they are not the same, isn't it? So you say, therefore, probability of A and B is not the same as probability of A times by probability of B. So we say they are not independent. Not independent. So there are two ways of checking independent is to use this formula. This is method 2. Or you can use method 1, which is this. Both are acceptable. $20 out of 100 is 1 out of 5, right? 20. 4 times 5, 20 out of 100. Right, get the idea? Now, where does that formula come from? This is coming from, let me try to show you where that comes from. So if we look at the conditional probability, probability of A given B is equal to probability of A and B over probability of B, isn't it? So therefore, to calculate probability of A and B, probability of A and B, this is same as probability of B times by probability A given B. So if the two events are independent, if it's independent, what does this equal to? This equals to probability of A, isn't it? If independent. So therefore, you can see that where this formula comes from. So if it's independent, it's same as testing whether this equals to A times B. That's another way to check whether they're independent. All right, good. Any questions? Right, you should start exercise 3G today. Okay, all right,